Look at this calculation. Setting up 1,000 times 945 on paper forces you into a tedious stack of zeros and shifting rows. But mentally, it is just the number 945 with 3 zeros tacked onto the end. Those trailing zeros create a false sense of cognitive overload. They look heavy, but they are just empty placeholders. We are going to learn how to mentally detach, store, and return these placeholders to solve massive problems in seconds. Take 9 times 5,000. Visually mask the zeros to isolate the core calculation, 9 times 5. That is 45. Now simply take the 3 zeros held in your mental bank and attach them right back onto the end. You get 45,000. In multiplication, you do not need to process zeros during the actual calculation. You just park them on the side and pick them up when you're done. When numbers have trailing zeros, the logic scales up. For 50 times 300, separate the core numbers, 5 and 3, from the zeros. 5 times 3 is 15. Add the 3 set-aside zeros onto the 15 to get 15,000. Look at 60 times 500. Bank the 3 zeros. 6 times 5 is 30. Because 30 already ends in 0, do not let it blend with the banked zeros. Write the complete core product, 30, before returning the 3 banked zeros to reach 30,000. Try applying this to 40 times 50,000. You have 5 seconds. First, bank the 5 trailing zeros. Multiply 4 by 5 to get your base product, 20. Finally, drop all 5 banked zeros behind the 20. The answer is 2 million. Respecting the strict boundary between the core product and your banked zeros is what prevents order of magnitude errors. This text excerpt explores how quotients and differences relate. We need to shift our logic here, because finding a quotient, division, handles zeros differently than multiplication. Let's look at 400 divided by 20. Instead of banking zeros, division requires a 1-to-1 cancellation. Because 20 has 1 zero, you strike out exactly 1 zero from both sides. The problem simplifies to 40 divided by 2, giving you 20. As the text moves on to discuss finding a difference, we see that subtraction shares this requirement of only addressing common zeros. Think about 7,000 minus 4,000. Both numbers share 2 trailing zeros, meaning they can both be measured in hundreds. By mentally reading the problem as 700s minus 400s, you get 6600s. You then write out 66 followed by 2 zeros, 6,600. Multiplication collects all zeros, but division and subtraction require you to eliminate common zeros to keep the place values perfectly aligned. The real test is applying the right rule when the operation changes. Let's run a quick drill. 600 divided by 20. It is division, so strike 1 zero from each side. 60 divided by 2 is 30. 50 times 50. Multiplication. Gather the 2 zeros. 5 times 5 is 25. Attach the 2 zeros for 2,500. 10,000 minus 4,000. Subtraction. Shift your perspective to thousands. 10 minus 4 is 6. The answer is 6,000. Methodical. This matrix summarizes the strategy. For multiplication, gather all the zeros. For division, cancel zeros 1-to-1. And for subtraction, align them by place value. By separating these distinct zero shifts, the mental drag of massive numbers begins to disappear. What once looked like intimidating arithmetic on paper is now a structured, predictable process.